Hello and welcome to Chapter 11 homework. If you got a delay, I apologize for that. Just because I have to wait to make sure that the buttons actually show up on the recording device. It happens. But I do commend you to come all the way for Chapter 11 and learning about two sample hypothesis testing, which brings on some very, very fun formulas, which we all found out in the PowerPoint. But without ado, we're going to be going through the questions for Chapter 11. And I just want to remind you that, again, if the question starts to repeat itself, like one that I've already talked about or done the example, I probably will not go over it. Just because I do need to know if you can use that awesome critical thinking skill and that smartness that y'all have, because I know y'all are very smart, to be able to solve those problems. Don't worry, I'm going to give y'all some tips and tricks of how to handle it, including using Excel. Ding, 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 ding. Alright, so we're going to start with just a simple problem here. So it says a sample of 36 observations is selected from one population with a population standard deviation of 4.2. The sample mean is 101.5. A sample of 50 observations is selected from a second population with a population standard deviation of 5.0. The sample mean is 100.1. Conduct the following tests of hypothesis using a 0.10 significant level. Okay. So, with that, we're going to go through. Okay. Now, first thing that we know is that because it's a population and we do know the standard deviation, this is going to be a z-score. Even if the question already tells you if z is blah, 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 you should already know that when we have a known standard deviation. We also can tell by the hypothesis, the null and the alternative, they have our classic equal signs, equal and do not equal, so no greater than or less than. So that immediately tells us that this is going to be a two-tail. Okay. Next, we need to figure out what z is. All right. So, using our fancy calculator, always make sure to clear it. Since we have a 0.10 significant level, remember, take 100 minus 0.1. Wait. We're supposed to take 100% minus 10%, be 90. Or basically 1 minus 0.10. Okay? Then we're going to divide that by 2. Because we got a two-tail. This leaves us with 0.45 in each of those tails. That basically, if the z value that we end up having falls within these parameters, we're going to reject. So, it's got to be outside the intervals of that 0.45, so we need to go look up the z table. Here is the z table. Yeah, boys, kind of thing. I'm sorry, this is like, every time you get z, especially with my age, it always reminds you of the 90s. I know I make that joke a lot, but alright, so we're going to be looking for 0.45, the closest one to it. Okay, I see right here 0.4505. Now remember, we can't go over that 0.45. So best one we got is this one right here. As close as we can get to it, so that's 0.164. 0.164. So negative 1.64 and a positive 1.64. Okay. Check to make sure you did find a significant level, which we did. Remember, always do negative before positive. It's just the way that the timeline works. I mean, I'm sure Connect could take the switch, but just get into the habit to try and put the negative beforehand. Alright. Now, it's time to compute the Z value. Now, from your PowerPoint, we know if it's a population sample size that is known, it's going to be this fancy formula. Yay! So what we're going to try and do is we're going to break this down and use a little bit of tech, and we're going to put it in Excel. Now, when we put it in Excel, as it is right here, notice that I've got both our sample sizes, or population sizes for this one, and I took the main ones, mean, standard deviation, size. This way I can break down the problem and go ahead and actually see what numbers I'm working with. So starting off this, I have a sample size of 36 observations. So 36. We have a standard deviation of 4.2, and the sample mean is 101.5. Okay, so that's our first population that is told to us. Next, we have the 50 sample size observations with a standard deviation of 5 and a mean of 100.1. Awesome. Okay. Now, we got to take all this info and we're going to put the formula together. Okay. Now, easiest way to do it is to break down each one. So we're going to go ahead and do the fractions that we know. So this is going to be equal. So our variance equal in parentheses. Find our formulas. Go math. We're going to find square. So that's square root. Square root returns. There's our power. So this one, it's called power. Yes. So whatever the standard deviation, we're going to do square. Okay. They don't like the multiple parentheses there. So we're going to divide it by our sample size. Okay. Now that we know that, we're going to go plus comma 2. And yes, it does take a little bit to build the formulas, but once you got the formulas in, if I come up to another problem. So if I come up to another problem like this, all I would have to do is insert the numbers to actually figure out what the problem is. I don't have to constantly enter into the calculator. Sometimes it's almost working a little bit better. So we know this is our variance for this 2 sample. So there's variance right here. Yay! Alright, so let's go ahead and get the square root. And notice that I am labeling everything as we walk through. This way, in case I do know that it's not equaling to something, we can always check the formulas. So again, formula, math trig, square root. And again, I'm breaking it down. There is always more stuff in Excel that we can actually use. But we're just going to go with the pattern right here. Now, let's finish up the formula. Let's go test stat or equal to, in parentheses, our 2 means minus each other, close parentheses, divided by our now square root. So this comes out to 1.40, and most likely they're going to tell you to usually round to 2. So we're going to go ahead and do that also here in Excel. So I'm going to go to home and tell it to go only down to 2. So now it tells me it's 1.41. We can check. And there we go. Now, every time that I have something that's with population and it gives me all the information, guess what? I have an Excel document that I can insert the numbers and have it calculate for me, where I can test it out to see if it's correct. Now, question is, for our problem, will we reject or not reject? Well, 1.41, does it fall outside? Is it greater than 1.64? No. So, since it's not, we do not reject. If yours was greater than whatever your significant value is, then yes, hit reject. Again, each step, try to do check my work just to make sure you're understanding the material. Now, it asks, what is p-value? This means we need a chart. So, we do know that we are dealing with this test stat of 1.41. Okay, fine. Woohoo! Let's go find it on the chart. Looking on the chart, looking on the chart, looking on the chart. Okay. So 1.41. There's 1.4. And then we're going, what is it? Yeah. So 1.41. So it is 0.4207. Okay. We're not done yet. Okay. So using our calculator, we're going to take 0.5. Remember, because these are always one side of the tail. Minus 0.4207. Okay. And since it's a two-tail, times it by 2. Shows that our p-value is actually 1586, which means about almost 16% of the chances that we do this is testing error. If we accept null, that could be wrong. Yes, fun stuff. Probability of that. And it does say round 4 decimal places. Okay. So calculator 0.1586. And there we go. That's question number 1. Okay, now that we got question 1 out of the way, hopefully that helps a little bit, seeing how I processed the Excel and converted our formula into a little bit easier way. Now, again, there's stats, formulas that are there for y'all, and y'all can look up those stats and see if any of those really work for you as well. Because, I mean, we can see it through it. Like, there's a t-test one, and so forth and so on. I like to break it down just because, again, we're learning more, and we need to get the basics down. So the more you can see how the formulas are breaking down using the numbers than just highlighting and run through, the better off. That's why I didn't really do the standard deviation with the formula until later on, where you can see where I broke it all down in the previous chapters. So now, let's go ahead and go to question 2 and see what fun we get to have. And you're like going, yeah, it's not going to be fun. Nah, it's going to be fun. It's always fun. Alright, so we already know we got a two-tail. We have the null, and we have the alternative, again with the equal signs. This time we have a random sample of 11 observations from one population, reveal a sample mean of 24, and a sample standard deviation of 1.3. A random sample of 5 observations from another population revealed a sample mean of 25 and a sample standard deviation of 1.5. Already, since we're working with samples, we know that the population significant standard deviation, is unknown. So since it's unknown, this will now become t. We're looking at the t value. And since we're dealing with a little bit more fun, we already know, if I show you the formulas, see if I can show them with the big bulk. Yeah. So we'll have the pool variance right here, the fun pooled one. And then we're going to have, again, the test statistic. Okay. So they're going to be fun, but we're going to break them down. Now, first thing that we have to do is figure out our decision rule. Where do we end up rejecting our null? So remember when we calculate degrees of freedom, when it's 2 sample and they're equal. Again, difference there is that these we're considering equal in the way that the reason why we're pulling them. So calculator. So our degrees of freedom are going to be the combination of our sample sizes. Okay, so 24 plus 25 minus 2. So our degree of freedom is 47. Okay, so now we go to our handy dandy chart, find our t distribution. We're looking at a 2-test. And for mine, they said the significant level was 0.10. See, there it is. And we're looking for 47. Here's 47. Okay, and 0.1 was the second column. Which is right here. There we go. So 1.678. So again, negative 1.678 and a positive 1.678. Did I do the wrong one? I did the wrong one, didn't I? For some reason, I'm thinking 24, 25. That's the mean, ain't it? Always been. Okay, so 11 plus 5, which is 16 minus. Sometimes you have to laugh at yourself when you make a mistake. Mistakes happen. It's like, we do look at all these numbers. So, it's actually 14. My bad. I'm like, why is it wrong? Then we realize, oh, we took the wrong numbers. That's okay. If you can't laugh at yourself at making a mistake and learn from it, then But no, we got 1.761 now. That's why I say check your work so you can understand. So negative 1.761. And positive 1.76. Trying to show y'all how to do it, and I mess up like that. There we go. Again, make sure you do the observations. You're like going, why did he use those numbers? And it's like, because for some reason my mind thought they were the observations. It happens. Alright. So there's our t-value. This is what we gotta watch out for. Alright. Now we're going to compute the pool estimate of population variance. So again, I'm going to do this in Excel. Now I do have two tests right here. This is why I can keep everything in one Excel. And if I did this, this probably would have shown me, like, oh yeah. So I have 11 and a sample mean of 24 with a standard deviation of 1.3. Okay, I'm actually going to eliminate that column. Bring it a little bit closer. Just a little bit closer. I'm all alone and the nights are so cold. Dun, dun, dun. Okay. And we enter in the information. Hey, there we go. So now it's time to do the pool sample. Okay. So let's get the formula so we can see how this is going to look. And it looks like it's going to be a lot of fun. So we're going to start putting it in parentheses to equal. And we're going to do both the denominators basically together. So the different parts of the fraction, like separate, and then we're going to bring them together to do this all at once. I know, looks like a sad face. So, pool variance. I'm going to do it step by step. Again, so first part, we're going to have N1, which is size. Oh. So our size there, minus 1. And we're going to multiply it by power of our standard deviation, comma 2. Okay. Plus our sample size, minus 1 for population 2, multiply by power of population 2 standard deviation, comma 2. Okay. So there's 25.9. So this is the numerator. And yes, I'm spelling probably a little bit bad on that. So denominator. It's like people are going, oh my God, his spelling. It's okay. As long as we know what it is, helps us out. So this is going to be our bottom part. So that is sample size 1 plus sample size 2 minus 2. Okay. Now, I want to actually put this in a color. So, oh, not bright yellow. Let's do something a little bit less hurtful on the eyes. There we go. So this is going to equal to that number divided by this number. And we got 1.85. Okay, let's see if the formula works. If not, this is how we experiment. Okay, 1.850. And it is correct. So now I have the pole variance in Excel. So if anytime I need to change these numbers, actually I didn't use the mean, so change the numbers of the ones you're using in the formula. So if this is now became sample size 16, you can see it change. Okay, or I have a new standard deviation of 2.5. Okay, so now we have something to help us out later on, especially with these workout problems. Okay, now hopefully this is something that you've been working on, but if not, I'm hoping that this is being very helpful now, especially with these more complicated formulas. Let's use the technology that we have. Now, would this mean that you probably will go and need to be knowing this on an exam? Yeah. Still know the formulas. But this makes it a little bit, tad bit easier for you to do it for the homework. As long as you're getting the understanding, I am more power to y'all of using the technology that we have. Alright, now it's time to compute the test statistic. Alright. So just like this one, we're going to go ahead and take these. Actually, I'm not going to copy those. I want to do it this way as well. Test stat. We're going to have the variance, square root of that, and then we're going to calculate our test statistic. Okay? So, variance. Again, to me, the variance is always in the square root. So we need our formula. Formula! Formula for statistics. Yes. I know, sometimes you're like going, man, this professor's just a little bit interesting going on. It's okay. We rock. Alright, so we know for the variance, or what's going to be inside the square root, is our pool. So that's why we have to figure that out first. And it's going to be multiplied by 1 divided by sample size 1 plus 1 divided by sample size 2. Okay. So enter. Then we know we're going to square root it. So square root, parentheses, that one. There we go. Again, you can go to formulas and pop up the formula if you want to. Or you can type in square root and put that in parentheses. Now, we can do it just like we did for population. Where we're going to take our means. Okay. So, sample 1 minus sample 2 divided by our square root. We're equal to negative 0.36312. Double check, since I know I was messing with the means. Alright. So, again, it says round 3 decimal places, so we're going to go ahead and do that by going home and reduce it to 3 decimal places. Again, I'm going to go ahead and color this. I'm going to color this light green. Okay. Just so that I can see what it is. So there we go. This is negative 1.363. And there we go. So it has been calculated. We've done them both. Alright. State your decision about the null hypothesis. Okay, so we're going to take this test statistic and we're going to look and see if it's less than negative 1.761, which means it has to be a greater number than what we have as a negative. It is not. So that means I do not reject. Do not reject null. None shall pass. Okay. Again, you can always check to make sure. And now it's time to figure out p-value. And p-value, again, we're going to take our test statistic and we're going to find it on the chart. Now remember, we got to stay within 14, the sample size. And we're going to see where 1.363 will fall. And it's going to fall in between the first 2 columns. So between 0.20 and 0.10. So right there between 0.10 and 0.20. Okay? And there we go. There's question 2. Now, again, it takes a little bit longer because we're setting up Excel. But let's see if now it's starting to repeat. Probably not yet, because we may have the equal, non-equal, not equal, but we're going to find out. Ooh, it jumps up a little bit. All right, so Miss Lisa Monin is the budget director for Nexus Media Incorp. She would like to compare the daily travel expenses for the sales staff and the auditing staff. She collected the following sample information. At the 0.010 significant level, can she conclude that the mean daily expenses are greater for the sales staff than the auditing staff? Okay, so that would mean our hypothesis would actually have it where daily expenses, which I'm figuring is daily expenses for the sales staff are greater for the sales staff, so that'd be the greater side, than the auditing. Okay. Nice. So again, we need to figure out our numbers. And we're dealing with this 0.01 significant level. So again, the only thing that we can do, since now this is a one-tail test, because we don't have equal. We're not dealing with are they the same. We're dealing with sales staff actually going to be greater than auditing. That's our alternative. So this 0.01 significant level, we would go to our table, find our table, and we're looking at one tail. Put that in blue. Okay. So this is the column that we're going to deal with, which is the 1, 2, 3, fourth column. We got to find our degrees of freedom. So calculator. We're going to take 1, 2, 3, 4, 5, 6, 6 plus 1, 2, 3, 4, 5, 6, 7, and then minus 2. So it's going to be 11. So that's our degree. So we're going to be looking at the fourth column for 11. So remember, this is where we find our p-value as well, our probability statistic. So 1, 2, 3, 4. So we should be looking at 2.718. Double check. Yep. So 2.718. There we go. This time, not taking the wrong numbers. Alright, so now we got to compute the pool variance. Problem is, we have Excel data that we have to deal with. And our Excel currently will only show the pool variance if we have the mean, standard deviation, and size. Now, we do have the size of our 2. So 1, 2, 3, 4, 5, 6. And we can delete all this if we want to. So we have 6 for 1. And we had 7 for our sample size 2, which is our auditing. Now we got to compute these two. Alright, so we're going to pop up that Excel. Click to download. Okay, enable editing. We're going to quickly find the mean of each one. File, not file. Formulas, auto sum. Tell it to auto sum. And then pop 1, pop 2. Or we can go sample 1, sample 2, however you like to label. So, mean and standard deviation. So, equal to that, divide by 6, 142. This is going to equal this, divided by 7. So we're at 125.286. Huh. And now standard deviation. We can go formulas, stat, and find standard deviation, sample. Tell it to go okay. And then go equal. All right. So we've got some fun formulas right here. So hopefully rounding doesn't hurt us too much. So I'm going to go ahead and put the means in. And currently the means aren't doing much for us, but I just like having them in just to keep everything proper. So 11.2071 and 14.2328. All right, so got our standard deviations in. We know pool variance should be about 167. And it said 2 decimal places this time. So 167.59. I check. There we go. See? Again, just input. And this already has our test statistic because we already got it set up. And 3 decimal places, so it is 2.321. And boom. Using Excel, bring in fun. All right, so our question is, are we going to reject? So go back to our decision rule. We only reject if our t-statistic is greater than 2.718. It is not, so we do not reject. Again, if it does fall where we reject in our decision rule, you do select reject. So you hit check. And there we go. And now it's time to estimate the p-value. So again, we go look up that 2.321 on our chart. Since it was PowerPoint. So since it was 11, we look up right there, 2.321. And it's going to fall right in between these two. Notice again, because we know where the t, where our parameter is, kind of figure it's going, if it's not greater, it's going to fall on this side. So it's going to fall between 0.025 and 0.01. There we go. Just happens to be the first one again. I got lucky. So there's question 3. And question 3 actually got to be used a little bit easier with our Excel. The only difference between question 2 and question 3 was that we had to do a little extra work with doing the Excel document. But once you start getting those formulas in, Excel becomes a lot easier to handle. All right. Question 4. The null and alternative hypotheses are. Again, we got a greater and less than, so we know that it's one tail. And now we have an unequal variance test. Okay. So a random sample of 23 items from the first population showed a mean of 112 and the standard deviation of 10. Okay. A sample of 17 items for the second population shows a mean of 106 and a standard deviation of 10. Use the 0.025 significant level. All right. So I want to go ahead and make sure I separate these in my Excel. So right here, if you ever need to and you want to copy most of the formulas and information, always hit move or copy. We're going to create a copy and move to the end. Okay. I'm going to rename it to unequal. Okay, because we may need to use different formulas, and we have degrees of freedom now. So I want to delete those. And we're going to shift everything down a couple. Okay. Makes it look a little bit better. So now we have degrees of freedom. Okay. So we got to deal with this formula right here now. Because we're dealing with an unequal. But we still have our good numbers. So again, random sample of 23 items. 23 shows a mean of 112 and a standard deviation of 10. And then the second population has a sample of 17 items with a mean of 106 and standard deviation of 10 as well. Sometimes you get lucky. Both of them are the same. But this is would be if it's equal. Let's see if what changes. Okay. So the first thing that we have to do is compute the formula for degrees of freedom. So let's go look at our PowerPoint. We may have to zoom out just so that we can see it just a little bit better. And here's our unequal. So it does change. Look at the test statistic. Okay. And notice that we don't really have a pool now. It changes just a little bit. So that means our formulas will end up changing. In fact, we're going to go ahead and remove this. Because as you can see from our PowerPoint, we just use the degrees of freedom and then we move forward. Okay. So let's go ahead and put this in. So this goes bye-bye. Okay. Now the fun part. Let's zoom this in so we can see it better. And definitely we're going to change this to... We'll actually have 3 columns. I want to do 3 columns here just because of all the powers that we've got going on. Let's go ahead and try and do our best. So, yeah, we're going to have to break this down just a little bit more. Well, let's give it a shot and see how it works. So, first off, we have power. And now we got to figure out the number. So, our number, which is going to have a lot of parentheses, it's going to be our sample deviation. So, it's going to be power of our standard deviation from population 1, comma, squared, close that one, divided by size, now close that PowerPoint, plus another one, which is our sample size 2, which has to be in power, sorry. Comma 2, so that's squared, divided by sample size 2. Okay. So we have one power. So I don't think we need that parentheses. Okay, comma 2. Let's see how it works. See if the formula works. Oh, the formula works. Yay! Now we're going to actually see if we can get all this together. So again, we're going to break it down. Power of our standard deviation 1, comma 2, divided by, whoops, that's supposed to be that one, divided by n, comma 2, and divided by n minus 1. Okay. And we'll copy right here, plus paste. Same formula. Now we're just going to put our other ones in to replace. Okay. There we go. And we'll go ahead and put in parentheses each one, just to be safe. Lots of parentheses. Okay. So I've entered 2. So that means I would have done it with that one as well. Okay, so now this is the fun part, is actually getting all the parentheses in correctly. Okay, so I see what's going on. So it doesn't like how I'm putting it in. So let's delete. Okay, delete those two. There we go. Okay, I had too many parentheses, seems like. Alright, so this is going to equal to our numerator divided by our denominator. So our degrees of freedom, and this is always going to round down, so always remember it's just going to be the whole number, but we're not going to do what we've done with doing the decimal places, because then it will automatically round up. Okay, so we're going to just keep it like this, and just remember it's going to be 34. Alright, fun stuff. Now the formula is built in though. So let's go ahead and make sure that is 34. And there we go. Got our correct answer now. Okay, and now we've built the formula in Excel. Takes a little bit, yeah. And again, we can probably, odds on there is a formula just from statistics. Probably that does degrees of freedom. Wouldn't surprise me if there is. But that way you can actually see how it all pieces together. And again, that takes a lot to put that power. I've got the power. So again, just takes a little bit to make the degrees of freedom. And if you want to piece it out even more, you can, just so that you can see how each of the formula functions go. Alright, now that we have degrees of freedom, being 34, let's go find our answer to our decision rule using our table. And now I have 0.025. Put this in pink. Okay, and we're going to go to row 34. This is going to be the row that we're going to be using. Okay, in pink. And that was third row. So it's going to be 2.032. 2.032. Check. There we go. Now again, this question has a hint, so maybe McGraw-Hill will throw you a different direction. It all works. Whichever direction that helps you out the most. The more evidence we use. Okay, now it's time to compute test statistic. So, here, let's go ahead and make this our color again. Alright, so test statistic is changing. We lost the reference because we're no longer using pool variance. Okay. So, let's go find the formula for test statistics. Well, we need our Excel too. So there's our Excel. Here is our test. They just both want to, it's like, we don't want to work with each other. So quit putting us together. Okay. So here we go. So you know how I like to do the variance, the one that's inside the square root. Okay, so again, unequal variances. So we're going to go ahead and delete. And we're going to put in parentheses, our good friends parentheses, power of our standard deviation, comma 2. Okay, and then divide by sample size plus, oops, to make sure we got close the parentheses, and then plus power of our standard deviation 2, comma 2, close the power parentheses, divided by our sample size in 2. And since I already had the square root, boom, there's the square root. And it still would subtract the 2. So both our means are subtracted, and we come out to 1.876. Let's see. And there we go. There's our test statistic. Already calculated for us. Yay! So hopefully this is becoming a little bit easier to follow along now. And make this chapter just a tiny bit easier. What we're trying to do is see if you can use the critical skills to know how to find our course decision rules, how to figure out degrees of freedom, just figure out these items. So, again, decision rule, t had to be greater than 2.032, is 1.876. So, our null hypothesis cannot be rejected. And there we go. There's question 4. Go ahead and hit question 5. Okay. So question 5 states this. A recent study focused on the number of times men and women who live alone buy takeout dinner in a month. Assume that the distributions follow the normal probability distribution and the population standard deviations are equal. Okay. Now if we're using our fancy new calculating software that we're creating, since it said equal, in fact, we're going to rename this as equal. We're going to be using probably these formulas. Alright. They summarized it already for us. Since it's all sample, we do know it's the t already. At the 0.01 significant level, is there a difference in the mean number of times men and women ordered takeout dinners in a month? Okay. State your null and alternative hypothesis. We already know this. The null will always be equal. It will never have do not or no equal. Okay? And they're always opposite. So that would immediately mark out C. And B, of course, has it the opposite way. So that means our first one is correct. Check. Yay! Okay. Now we've got to compute the test statistic. Wow. They just jumped right there, didn't they? Okay. You want us to compute the test. We'll go and compute the test real quick. So, you're going to go, oh my god, now it's become very easy. Yeah, just takes time. So, first population, 25, 5.58, 32. Our women, 22.28. It's sample 4.98, and the size is 34. Okay, so here's our pool variance, if needed, and our test statistic is popping out at 2.484. Check, make sure our calculation is correct, and it is correct. Alright, next, it wants to compute the p-value. Okay, the only thing that we have to do with the p-value, again, is find our degrees of freedom. Since this is equal, we take our two sample sizes, add them together, and subtract 2. So we're looking at 64. Wow. I don't know if our table hits 64. Let's go find out. It does. Wow. There's 64. We'll do it in blue. So now let's look for our t statistic, which was 2.484 on this row. And we're going to find it between these two. So since it's a two-tail, it's between 0.02 and 0.01. They actually want us to compute this. Okay. So they really just want us to put it into a p-value calculator or statistical software. Let's see here. Sometimes these questions they bring out these like fun answers. So let's see if we have a stats formula for p-value. Okay. So there's our variances. No. Oh, right. I love that because, again, we're looking at pretty much nothing on p-value. So let's see if we can look for a p-value calculator. P-value calculator from T. Alright. Let's see. What was our significant level? It's 0.01. This one actually has it. Again, good Google search. T statistic was 2.484. And our degrees of freedom was 64. Again, we can check with our book. That's all the way, yeah, 64. Let's see if this works. This is a two-tail. So I got 0.01562. Okay, check. And there we go. So that one you will have to kind of Google. So I found this quick p-value, as you saw. I just did real quick Google search. Type in our answers. And boom. There it is. Yeah, that I don't know why they do that with the p-value. Sorry about that, guys, because I am only a few questions I can select. But yeah, my question is, does the book actually show step by step? Let's go look real quick. let's see, very quick chapter books. I know this is the homework, but I want to make sure. Because I think that's what they're doing no matter what, is telling you to calculate the p-value using statistical software or a calculator. So we're going to say right here. Actually, we're going to search the book. Yeah, they're going through all the statistics. I mean, not the this is a statistic course, but it looks like they're going through a software. See, I just need the formula. Yeah, this seems like they're not really providing us with much. Let's see here.
Variable 1 range is the before column. Variable 2 range is the after column. Our hypothesized mean difference will put a 0.
Yeah, so this is dealing with all the differences.
We have a 0.01.
Okay. So yeah, this is all dealing with differences. So yeah, that's odd. So it does tell us to go ahead and look at a statistical software or p-value calculator. I'm going to tell you real quick. Go ahead and Google a p-value and input the information. That will make it a lot quicker as we go. And if I do find out what the Excel, I'll definitely do it in Excel for y'all. But yeah, that's an odd way. I'm going to try and avoid these. I'm going to be honest, if you're watching this video, I'm going to try and avoid a compute the p-value problem on your exam. Okay? I just rather you know how to do the charts. It's a little bit easier in a sense that it helps you with the knowledge. It still falls within between, so it rocks. Okay. Now, real quick, we can actually go look up our t-value. We know it's 64. And we're dealing with a 0.01 statistic. So let's go ahead and get, whoop, not that. Okay, so let's go ahead and look. We know it was 0.01. It's a two-test, or two-tail. So that was mine. Yes. And we know it was at 64. So second to the last column. Okay, 64. So it should have been 2.655. This is what we're going to reject. And we currently have 2.484. So we do not reject. It's not greater than the 2.655. Do not reject. Okay. Turn to question. At the 0.01 significant level, is there a difference in the mean number times the mean men and women order takeout dinners in a month? Since basically we're showing that we are not rejecting the null, we're saying that they're equal, so there is no difference. Okay. So really the only tricky one of this problem is the p-value. Okay. Once you figured out your t-statistic or test statistic, again, we can find a quick p-value calculator and go ahead and let it calculate itself. In fact, that's even suggested, again, by connecting it itself. And I'm going to go from your point of view. Works. Question 6. And again, another compute the p-value. So this little website's going to be our fun. Okay, so a coffee manufacturer is interested in whether the mean daily consumption of regular coffee drinkers is less than that of decaffeinated coffee drinkers. Okay. Right here, I can already tell you with the choices that I have, that the first one's going to be the correct one due to the null having the equal sign and the other two don't have it. Remember, null will always have an equal sign, even if it's greater than or less than. Okay? But we're going to assume the population standard deviation is 1.90 cups per day for those drinking regular coffee and 2.06 cups per day for those drinking decaffeinated coffee. A random sample of 57 regular coffee drinkers show a mean of 4.38 cups per day. A sample of 47 decaffeinated coffee drinkers show a mean of 5.87 cups per day. Use the 0.010 significant level. Now, here I can see I have population standard deviation. So this is just like question 1, where we know we deal with z-value. Okay. So, in our little Excel calculator that we have created, we know we have a population. So immediately, do we? All right, we do. Okay. So, standard deviation. Okay, yeah. A lot of words had to piece it together. Okay. It's not easy when you can't highlight. So, a print out, highlight if it helps. But, okay. So, our Excel, population 1, which is going to be our ones that drink regular coffee. So that we sampled 57. Standard deviation is 1.9 cups per day. And sitting at a mean of 4.38. Or our decaf guys are 47 with a mean of 5.87 cups and a standard deviation of 2.06. So our test stat is showing a negative 3.80. Check. And we are correct. Okay, now it's time to compute the p-value. Since this is a z chart, this one's a little bit easier. T-value is the one that's the tough one that we need p-value calculator. So z-value, we can go not to calculator, to our table, go right here. We're going to look at 3. If we have it. We don't even have that. Oh, it's not that one thing, it's another. So, Z table. Let's go look up a Z table. Let's find one that helps us out a little bit. Okay, yeah. So we're going to just go ahead and use this one. Alright, so this, like how I'm trying to expand, and the picture won't visit. Okay. So this one's a fun one. This one actually gives us a negative side, which works, and it gives us the positive. Hey, sometimes we have to use what we can get. So my z-stat was 3.80 negative. So this is going to end up being 0.00007. Nice. So back to the homework. It just has this. So it is less than that. Okay. I like how it just gave me a choice there. But we had to go find a z-table. Sometimes that just happens. So I'm going to keep that z-table and now our quick. So our objective to reject the null hypothesis. Are we going to reject or not? Well, z-value in itself because this is our test. We're dealing with a 0.01 significant level, which again is the 99%. So, calculator, 9 divided by 2. 0.99 divided by 2. 495. So, on our Z table. Find 0.495. Almost there. There we go. So it's right here, 2.5, 2.57. So yes, we're going to reject. Okay, because it is basically less than negative 2.57 is our test, or is our z-score that we would have done on the significant level, and this is less than that number. So the mean number of cups for regular coffee drinkers, if we're rejecting, is showing that it is less than our decaf. Okay, there's question 6. So compute p-value is a little bit easier again for Z than it is when they have compute for the t-test. It's always nice and fun when they say, use statistical software or a p-value calculator to solve this. It's always fun. Fun. Okay. So again, this one, see if this is ZRT. So a cell phone company offers 2 plans to its subscribers. At the time the new subscribers sign up, they are asked to provide some demographic information. The mean yearly income for a sample of 34 subscribers to Plan A is $48,450 with a standard deviation of $7,820. And I can tell you right off the bat, we're looking at T. So we're going to need a quick value calculator. And then we got, for a sample of 26 subscribers to Plan B, the mean income is $51,850 with a standard deviation of $6,552. Assume the population standard deviation are unequal. And we have an unequal one. Wow, they're having some fun with the question 7 here. So for right now, I'm going to go ahead and select 0.05 here for significant level. Okay. And degrees freedom box, we're going to go ahead and we're going to be changing that in just a sec. Alright. So first off, we do have a two-tail. Okay. So since we have a two-tail, again, let's check. Oh, they made this a lot more fun. So, we know C is gone because it's the same greater than or less than sign. They have to be opposites. We know that makes this one gone too because it's the same. So it's going to be the first one. But again, test your alternative. So they're looking at selected plan B is larger than select A, so it has to be greater than. And that is indeed what the alternative says. Nice. Alright, so we know it's unequal. So we have to go to our Excel. Go find our sample 2 sample unequal. So we know we got degrees of freedom. And we have our test stat. So let's input in our numbers. So population 1, which is Plan A, has 34 subscribers with a standard deviation of 7,820 and a mean is 48,450. Okay. Plan B has a mean income of 51,850 with a standard deviation of 6,052, and it hosts 26 subscribers. Alright. So we know already our degrees of freedom is going to be 57, even though it's very close to 58. We always round down. And our test stat is negative 1.898. So, again, it's calculated correctly. Here, we're going to look at our calculator. So, negative 1.898. And according to our degrees of freedom, we're looking at 57. And this calculates to 0.062764. I want to see if I can hit copy. There we go. Okay, it's a little off. Oh yeah, it's 1 till. It's not 2 till. So 1 till. Calculate. There we go. Copy. Now check. Yeah. So make sure you put 2 till and 1 till. Okay. Now, are we going to reject or fail to reject? And you know me, I like to use the test statistic a little bit more. So we're going to go to our T-chart. T-distribution. We had significant level of 0.05 on a 1 till. Okay, and our degrees of freedom were all the way to 57. So again, that was second column. So right here, it should have been 1.672, so it's either going to be greater than or less than that number. If it's negative, it's less than. So basically, if this number is greater than or looks larger, then it's going to be rejected. So table, and it indeed larger, so we're going to reject the null. Reject. Check. And we're good. Alright. So, since we're rejecting, which means we take the alternative, that does state that plan B is larger. Okay. That's question 7. Question 8. Looks like we got a 2 till. Okay. So we have music streaming services are the most popular way to listen to music. And it gives us all the information. Since we've already done this multiple times, and it looks like this is going to be this unequal. Yeah, are not the same. So it's an unequal one. So we just did this, except it just does 2 till instead of 1 till. So the only difference right here is making sure that if you're using this calculator that I'm showing in the homework, the quick p-value one, just switch it to 2 till, and you should be good to go. Okay. Yeah, nothing more else right there. So we're going to go ahead and see what question 9 has, because I know I've gone quite a bit. So it looks like question 9. See, make sure. Yeah, again, we're looking at not the same, so they're not equal. Even tells you take E-coupon as the first sample as a hint for the calculations. So again, another T with the samples. So this is going to be just like the ones that we just did in question 8. Question 7, 8, 9 pretty much are the same, except for one's 1 till and one's 2 till. And then this one, I really want y'all to kind of tackle. And this one, it has the population variances are equal. Okay. Number 10 is another T1 with our pool. Okay. So we've already done those. So we're going to leave those last 3 up to y'all to see how well y'all can use your critical thinking skills that are so awesome, and use the brain power and actually go through, because I know definitely this video has been long. And I hope that helps out. Hopefully the strategy of using Excel to help calculate the formulas instead of constantly retyping them into the calculator will help y'all guys out. If you do have any questions, please let me know, and I will see y'all later.